Today we're going to talk about like and unlike terms. So algebra is a branch of mathematics that uses symbols to represent information. In an algebraic expression such as 3x plus 5, we state that this has two terms. There's two terms because this says that there's 3 x's and 5 ones. So 3x is one term and 5 is another. So terms are always separated by plus or minus. So if you look at the first example, there's 4x and you're subtracting 3. So we have two terms here, 4x and 3. So there's two terms here. Then there's x squared minus 2x plus 5. That has three terms. X squared is different than 2x. So these are two different terms. They both have x's, but they're not the same. Then we have just the number 7. That's considered to just be one term. Terms can be numbers, like a 7. It can be variables, such as 4x, or the products of numbers of variables, where you have like x squared or 2x. So we can write all sorts of terms out. We can make them up as we go. Some examples of terms: 2x is a term. We have, I can say, negative 5 x squared. That's a different type of term. Just a number. 4 is a term. It doesn't have to be x. It can be any letter. We can have a 5y, for example. Those are all examples of terms. The number part of a term is what we call a coefficient. So if we look at 5y, the coefficient is the number that's in front of it. So 5. It tells us that there are 5 y's. If I identify the coefficient and variable parts of each term, so if I look at this chart, 5x, the coefficient is 5, it's the number, and the variable is x. Negative 3y, the coefficient is negative 3. So you take the sign with it, so it has a negative in front of it. It goes with the actual coefficient, and the variable is y. So here we have just an x, but there's an invisible 1 in front of there. That's saying there's 1x, and the variable is x. The coefficient for this one is negative 7, and there's two variables, a and b. When the variable letter parts of the term are exactly the same, then they are what we call like terms, which is a big focus of our lesson today. So here are some examples: 2y and negative y. They're like terms. So again, if you read with the definition, the variable part is the same, exactly the same, with the same exponent on it. So they're like terms. 2x and 5x squared are like terms. So you'll notice here it has the same x with the same exponent. Three and -4 are also like terms. They're just both numbers. We could say 2y and -y. The reason why they're alike is they also have the same variable. So unlike terms have different variables and exponents. So here you'll see that we have a 3x, 3, and 3y. Yes, they all have 3, but they don't have the same variable. This one has an x, this one doesn't have a variable, and this one has a y. So they are all different. So they're unlike terms. And here, these are also unlike terms because there's an x squared and an x. So this one doesn't have the squared to be the same as the other one. So they don't both have the same exponent. So you'll notice again, that's x squared and that's x, so they don't have the same exponent. Those do not make the same term. They're not the same. I can't add them. Okay, so example 2 says identify the terms that are like terms. So I'm going to look at A, and 5x is not the same as 3. There's no x there. This one has simply an x, so that's the same. And this one has an x as well, so that's the same. So those are alike. And then these two would be alike. 3 and -2. Okay, so we have two groups. So the first group is 5x, 6x, and -x. They all have just an x. And the second group is 3 and -2. They're just simply numbers, so they group together. In B, there's x squared, so same variable. There's a variable x and exponent 2. So if I want to find something that's like it, I got to find something with an x with the exponent 2. And the next one that goes with that is this one. Those are like terms, and then these two are like terms because that's just an x and that's just an x. that's my first group. And my second group is x and negative 2x. Here I have two other groups. I have 4x squared. So I'm looking now for something else that has an x with the squared on it. And I have this one. This one is just an x. There's nothing that goes with it. So it's not, there's no like term to go with that. But 7 and 5 are like terms. So this negative x does not have a buddy that goes with its like terms. So I have one group here, 4x squared and negative 3x squared. And I have a second group of 7 and 5. So in D, we're going to now look again. Here I have negative x squared, so you're going to find something with an x with the squared on it for it to be a like term. So that's x squared, and that's x squared. Then I'm going to look for something that goes with 3. So I need another number on its own. And here's my second one. And lastly, well, there's nothing to go with the x, but I did miss this 5x squared. That goes with that category. So this x, there's nothing that's like it because there's no other x on its own without it being a squared. So I'm going to put them in groups again. Okay, in math it is important to group like terms together and keep unlike terms apart. So we're going to keep like terms together and keep unlike terms apart. The reason why we do this, why do we want to put the like terms together? So we can add and subtract terms by adding the coefficients. So remember, the coefficient is the number in front of the variable or just the number by itself. So here, this means that I have 3 x's. And I have 2 x's. And I want to add those x's. So they're the exact same object. They're all x's. So I can simply do 3 plus 2, which gives me 5. And now together I have 5 x's. Here I have a 2y's, and then I get another 3y, so now I have 2 and 3y, and then I get one more y. So together, do it in steps, 2y's and 3y's, 5y. I'm going to continue writing the y down, and then I have 5y and 1y, so that's 6y. Here I have, they're all like terms, so I have m, and m with the same exponent. The exponent that's invisible is actually 1. I have 4 m's and I add 1, so now I'm 5 m's. I still have to subtract 2m from it, so I'm going to bring that down. 5 m's and I take away 2 m's, I'm left with 3 m's. Okay, so if we look at the next example, now we're getting more different terms. So if you look, I like to underline or make different symbols or use different colors to represent the different like terms. So I have a 2x squared. Find something that goes with it. So now I'm looking for another object, another term that has an x squared. So here it is. So I'm going to bring those together. Then I have this term here, so it's negative 3x, and I need to find something that has just an x, and here it is, 2x. So now add just the like terms, so 2x squared, and I have another 4x squared. So I add the coefficients, so the 2 and the 4. That gives me 6x squared. Then I'm going to do these separately. So I have negative 3x and I add 2x. So I add the coefficients. Negative 3 plus 2 is the same as negative 1x. In math, we normally don't need to write the 1. So we can simply write that as 6x squared minus x. They're both the same and both correct. So here it is negative 12x squared. Looking for a like term with this, you're looking for another x squared. And here's 5x. So I bring those together. So I'm collecting like terms first. Then I have a negative x and another negative x. So these are both x's with the same exponent that's just a 1. When you see negative x, and there's no number in front of it, the coefficient is always going to be that invisible 1. So it helps write it in. Then I have negative 12x squared, and I'm adding 5x squared. So you're going to do negative 12 plus 5. So there's more negatives than positives. My answer is definitely going to be a negative. When I think 12 minus 5, I get 7. And then you're going to add these. I have a negative 1, and I'm subtracting 1 from it, so it's going to become negative 2. Okay, now f. find your like terms again. So I have 2b squared. I'm looking for another b squared. So there's 3b squared. And there's no other b squared. So I'm just going to write those two together. Now I have 2b. And I'm going to look for anything with a b on its own. And here's another b. So I'm going to write those down. When you write them down, you take the sign that's in front of the number with it. So that's a negative 3b. So you notice the sign that's in front of it always goes with it. And last, what we have here is negative 3 and positive 5. So again, notice I'm including the sign in front of it with it. Now we're going to add them or subtract them depending on the operation. So I have 2 b's and I'm adding 3 b's. That gives me 5 b squareds. Now I have positive 2b and I'm subtracting 3b. There's more negative than positive. It's definitely going to be a negative answer. Then you just have to do 3 minus 2 and you get 1b. You don't have to write the 1. Then I have negative 3 plus 5. There's more positives. Definitely going to be a positive answer. And so 5 minus 3 is going to be 2. Again, you can write it without the 1, so you can have an answer of 5b squared. Just write it as minus b plus 2. Okay, so now on our next one, I have 2x squared here, so I'm looking for something with an x squared. Here's my other x squared. There's no other x squareds. Here I have an x cubed, and here I have an x cubed. So those together, and lastly I have a positive 9. So those are the first two. Notice again, if there's a plus, I take the plus with it. Here it's plus 6x cubed. Here there's a minus. And here there's positive 9. So the 9's on its own, so there's no need to add or subtract anything. So here's 2x squared plus 4x squared, that's 6x squared. Then I have 6x cubed minus 2x cubed, so I have 6 of these and I'm subtracting 2. So that's 4. And then last you're just adding 9. So again, like terms, you're just adding, subtracting, you're collecting the like terms, so anything with the same exponent or variable. So you're looking, these are unlike terms because they do not have the same exponent. These two have the same exponent with the same variable x, so you can add those. But these do not have the same exponent with the same variable, so you wouldn't be able to add those.